Okay. What is up, everyone? How is everyone? I want to wait to see what YouTube looks like because it's complaining about the ultra wide resolution. So, actually, I'm not going to wait because I need to see. I need to switch to code in order to see. Oh, that's the wrong one. Called ultra wide. There we go. Okay. Yeah, okay. So I think it looks fine. YouTube just doesn't like it. Oh well. Alright. Cool. Everything is looking pretty good. Alright. I guess we can get started. That music might be a little distracting. It wasn't a test. Oh yeah. We'll keep test. CD breakout. There we go. Clear. Do I have anything in here? No. Cool. Is the name.py. So I have not PyTorch. I have oh well, I guess I can do like an intro and all that stuff, all that good stuff. So hello everyone. My name is Twig. I'm gonna take a drink. In the middle of my intro. Yeah, lately I've kind of just been struggling a lot with programming and like what I want to do with my life, and kind of finding it hard to kind of further myself. Not necessarily just in my career, mostly my career, but also just in life in general, and just like kind of like what's my purpose and all these kind of higher order things. And one of the things that when I'm thinking about this, one of the things that I was kind of like missing is just all of the time, not all the time, but I was just like remembering when I was younger, early in my career, and how like everything was new and fresh and I liked everything. And I would kind of, my work ethic I think was a little better, and I don't really know what I'm trying to say. I don't really plan this, but I don't know. I just have this kind of existential crisis. I don't know if it's because it's so hot here. Oh my gosh, it's so warm. It got super warm right now. Well, I mean, just today. Sorry, just the weather in general has been warm. Like yesterday, today, and tomorrow are going to be fairly warm. So if you hear a fan in the background, that is because that is the AC. But anyway, I've just kind of been struggling with where I want to go in my life. I feel like I'm kind of at a point where I'm kind of jaded and lost the magic, if you will. And so I thought Godot would help that. But anytime I open up like a real IDE, then or IDE, a real engine, I just feel like I have to do everything correctly. And like I think this perfectionism that I wrestle with a lot, and I don't even know if it's perfectionism, just me like doing an endeavor to like be more, really prevents me from just doing shit and like getting shit done. So I'm kind of trying to take a step back, and then kind of just crank code out and kind of learn more about design and art, because those might be fun aspects that I want to explore as well. So yeah, the real reason, what really brought this on, Pygame specifically, was that I watched the Fluffy Potato. Here we can test the Fluffy Potato. I think that's how you spell it. Does that look fine? Yeah, okay. I think people can read that. Hope people can read that. Can I just increase font? Okay, we'll do it twice. Yeah, sure. Okay, so I watched a lot of his videos over the past like day, like literally yesterday, I think, and I don't know, I just was pretty inspired by uh, the things that he does, and just specifically his journey over the 10 years of like how he just made games no matter what the quality. He just did everything to the best of his ability, like solo dev, everything. And it was like really inspiring just seeing his journey, how much he's progressed in 10 years. It's probably over 10 years ago, but the video he made was like how he's progressed in 10 years. And I was like, oh, that's really cool. That was inspiring. Maybe I should strive to find that. So I think I'm going to, I just realized YouTube's encoding is incorrect. I changed Twitch Gnomecast. That's a bad habit of mine, getting distracted by stuff. But I think I'm going to try out some libraries and frameworks to kind of get down to business. Trying to get back what I lose when I open up engines, and kind of get rid of like preconceived notions of the quality of what I'm doing. So, let's see here. We're probably going to open up one of these. Throw that over there. Pygame. That's not what I wanted. About getting started. Oh no, I want the other website. Where's the other website? Doc? Docs? Okay, there we go. That's what I want. Okay, so I think we're gonna do this. Insert. Okay, cool. Wow. Breakout. Python. Main. Okay, cool. So we have the little dude here. We're in 720. Okay, cool. So yeah, my hope is that I'm going to play around with Pygame a little bit, see how I like it. I'm also kind of looking at Raylib. To be honest, I'm probably going to look at Raylib more in the future, but the goal for today is to start and hopefully finish making a breakout type game. Just in Pygame, just all in Python real quick. And then I think, so hopefully I'm going to finish that today, and then tomorrow probably going to finish up on Pygame, or finish up on the breakout in Pygame. And I think next weekend I'm going to do the same thing in Raylib and see how I feel between the two. And we'll see. Maybe I just love Python and Pygame, and maybe I'll just continue using Pygame. Who knows? But I'm trying to get back into like more of the exploration part of it. So I kind of want to explore more about various things. So yeah, let me make things more breakouty. Let's see, what is that, a rectangle? Let's go back to circle and let me rect. Okay. Rect. What does a rect need? Surface, color, we have that. The rect value. Width? Oh, border radius. Oh, that's fancy. We probably don't need that. I assume this is high-low. What? Okay. Okay, so just 4 values. Well, what are those 4 values? Is that, I assume that's XY min, XY max, or XY min, XY max, depending where 0, 0, 0 is. What's has rect attributes, rect value callable? Oh, maybe you should just look at the fucking documentation. Rectum. I hardly know him. Okay, so left top width height. Okay, so it's the men, I guess, because I assume 000 is up there. I guess I can just player pause. Where does player pause? Oh, okay. Just pygame vector 2 0 0. We'll just run that. Oh, yeah. Circle. Oops. Yeah. Okay. So. Oh, I can't move now. Oh yeah. Oh. Okay. Cool. That's neat. So this is a reference since I gave it a different thing and we're modifying player pose. So this has a reference to that and any modifications. Okay. Okay, that makes sense. So we're gonna undo that. So we want the player to be. Oh, how do we influence? Okay, but we can do it that way. Moves the rectangle. Oh, there's also a rect move. Okay. Dang, do you guys see? Can you guys read any of this? Okay, so that's cool. We're gonna see if that works, if this works specifically. So we're gonna try to make a tuple of the vector 2 position, and hopefully we can modify the player pause, and then what is it, width and height? 60-30? Does that work? Oh yeah, it does. Okay, cool. Yeah, hey, look at that. Everything works. Let's do like 80 though. Okay, yeah, that's more block outy. And then, what do we want? We want height, like minus 30, 40. Okay, cool. That's good. Yeah, that's pretty good, I'd say. And then we're going to remove W and S because we just don't want to. Delete 3 down. Yeah. Okay, yeah. So now we just move back and forth. It's a lot smoother on my screen, but yeah. Even though it's 60 frames. I guess I should. Whoop. Oh, you guys didn't see that. Okay, cool. So now we need the board and we need the circle. Let's see, the ball pose. Vector 2. That's going to be at the start. Oh, I wonder if it's offset. Because if the width is high, oh, maybe we need to go like minus 40. So the center of the box is actually in. Like this matters, but yeah, the center of the player rect is going to be like actually in the center of the screen. And so before it was like the leftmost edge was in the center of the screen. So I guess we fixed that, doesn't really matter. And then we're gonna have this, I think we're gonna have this be, how big do we want the ball to be? Oh, okay, so we tell it to draw a rect. Okay, oh, I forgot. Okay, so this doesn't have a reference. This is immediate mode. I didn't realize that we were in the running. Okay, so I thought for whatever reason that this just got, for both circle and rect, this just stored, like we created it like outside up here. I didn't realize we were in the loop. But yeah, okay, that makes more sense. So like we're just immediate mode, clearing the screen, telling it to draw a rectangle at the position, and it has this height or whatever. So that's cool. So now we can do draw circle screen. Oh, I think this is also going to be white. And then ball pause. Does this have like a thickness that I can adjust? Radius, yeah. Thickness of radius. So radius I think is 5. Oh, okay, so I wonder if that still has the same problem. Maybe. Actually, I think this needs to be okay, yeah. I think that's correct. Get width. Oh. Did I make height? Whoops. I didn't. I didn't. Okay. So now this doesn't move though. Kind of forgot exactly how breakout worked. I think it took the angle and the player velocity, and then it kind of just reflected off of maybe it was simpler than that. Okay, that's so what we're gonna do, I think, is we're gonna take the cube center, or yeah, I think we're gonna calculate the cube center. Cube center pygame. Whoa. And then, oh, is that just player pause? No. No, so the center is going to be this right now. Well, no, it'll just be Oops. Oops, spelled player wrong. Player position. Why? Okay. Plus. $15. Okay, so what I want, Milton, we're gonna so we're finding the center of the cube so we can figure out a direction vector for the ball to go at, right? And so if the ball was over here, then we would have a direction vector over here, right? And if the ball was here, then we have a direction vector here. So whenever you start, we're gonna just take that direction vector. I think. Oops. Oh, things are slow. That's not a good sign. Oh, hey there, Microsoft. Simmer down there, bud. Yeah, it's kind of warm. Kind of doing a lot. It's okay. Reset. See how hot we get. Oh, do I not need those? Okay, so I think that's center. Okay, alright. Cool, and then we're gonna go down here. Key. space. Whoops, I don't need those. Oh, it's okay. That's a weird distinction, but okay. So now I think we need a velocity, and I think we can just change that velocity. Okay, so we're gonna have ball velocity. So ball velocity pygame vector 2. Squeeze 0, 0. I don't need that. And whenever space is hit, we'll have to do conditions later. So like, if the game hasn't started, then and yeah, if the game hasn't started or we haven't already hit space for this one, then we can launch the ball. Otherwise we can't. Sorry, I was checking the stream. Okay. So let's see. How do I want to do this? This might be a short stream. I am super hot, super warm. It's only like 84 right now. It's supposed to be high of 88. Oh man. Be 86 here in a little bit. Oof, duh. Okay, alright. Let's push through. Okay, so ball velocity. So we're gonna set ball velocity. I don't know if a reassignment would be good or not. So how do we calculate that? We want the vector between I always forget which one you subtract first, because I think if you start with the ball versus the so okay, so this is 0, 0. This is what, like 1, 1? 1, 1. Yeah, so if you start with this and you subtract that, that's going to give you -1, -1, which will make you go that way. So yeah, I want to start from the cube and go to the ball. Cube center x minus ball pause x ball velocity y cube center y minus ball y. Do's rotate what? Okay, sure. Update. Oh, okay. Update is probably what I want to call. Oh, duh. I'm not using velocity at all. So now we need to I think we just need to take ball position dot x plus equals ball velocity whatever ball speed is. We'll do 350. I think I want it a little faster than the player can move, just so they kind of have to work for it. Oh, let's do delta time as well, because that would be crazy bad. Oh, whoops. Oh, that's fast. Oh, we're not normalizing it. We want a normalized vector. Do we? Oh, cool, we can swizzle. How does that work though? Wait, what? Are these the actual backing fields? Huh. T cross as polar normalize T vec. Just normalize IP. What is this using? Okay, actually pygame. Math. Returns a vector with the same direction but length 1. And this is the vector in place. But it's, oh, okay. So the vector is normalized, i.e. has a length of 1. Oh, okay. Oh, so this returns it. Okay, so functional versus not functional. Oopies. I think I just want IP. I should have copied that. Don't copy that floppy. Actually, what parameters? Yeah, just self. Okay. Should be better. Was I wrong? Ooh, that was special. I think it registered twice. Started balls. Is it and? Do you say and, or is it still the ampersand? We have not started. Oh, do you say not? And then okay. Oh, okay. Whoops. Did I do that wrong? Was my math incorrect? Lovely cube. Okay, so this is 2, 2. This is 1, 1. We're taking this minus the, oh, okay, yeah. Okay, I guess. Okay. Yeah, I think I was just wrong. Cool. So the only problem though is that I can't remember if breakout when you first start, I think if I remember, it stays in the center and just kind of runs with you, like right above you, and like I think whatever velocity, like when you release it, like however fast you were moving, is just kind of like how it went. Maybe I should just look up breakout. Not any of these. Okay, here we go. Yeah, I know. Just watch it. Just go to the YouTube. Thank you. That's nice.
Videos and things that I've seen. Welcome, this is Breakout by Atari, 1976. This actually is one of the close microprocessor, a logic board only, so you can't emulate it. There was no microprocessor to emulate, but they've tried to recreate it here as best possible, so we're just going to give the game of Breakout a shot.
Oh, okay.
And I tell you, it's not...
I feel like other iterations, like I've played different Breakout games, and I feel like other iterations you had like a start. Well, yeah, maybe we just put the ball in the half screen and we just picked a random vector down into the player, and the player just has to do the thing. We'll keep it how it is right now. Oh, my layup. Gosh, it's super warm. Let's see. Oh, I should quit Steam. So I don't leak all of my friends. All of my friends' information. Oh, you know what? I wonder if that... Okay. Because this wasn't the case, because I was thinking a grid started down here, right? Like that was 0, 0, and it increased like that. But that's not how it works. How it works is here. And it goes down and increases like that. So I was correct in that I should take the thing, I guess, closest to the origin. I don't know if I want to say it like that. Maybe that's correct. But yeah, I guess the thing closest to the origin. Subtract the thing that's further away from the origin. And that'll produce the correct direction vector. I think I was right in that. What I was wrong in is the coordinate system I was, using. So like this wouldn't have been the case. This would have been like, can I erase? Oh, that's super big. Okay, well, brush. So this would have been like 10, 10, and this would have been like 11, or like 12, 11 or something. Right, and so you'd want to take this, subtract this, to get the vector. Right, okay. I think that's why that happened, the why we had to change this. Alright, so I think the other thing we should do is we should now, I believe we want to reflect the velocity of the ball about the normal Does that make sense? I know I'm not saying the words to make it make sense, but I think we want the velocity to, like, if this was closer over here, if the velocity was going this way, right? And then we detect that we're about to go out of the frame, then I think we want to reflect against the normal of the thing we hit. So if we're going into, this is probably easier to draw. So that's the thing, and then this is the normal, and then the ball, is going to go into that. I think we want to reflect. I think we want to reflect this because essentially it's going to hit here, right, or thereabouts, you know, wherever, and then we want to go like that. Is that reflection? Do we want to like project it onto the normal? I forget the exact math operation, but we want to do math when we have a collision. So that's, I think, what we're going to do next, because that'll be kind of the basis for our collision. I think we'll want to do that regardless. I don't think we're going to do edge case, like we're not going to have like rounded corners. I think whatever we hit is going to be I think what I'm trying to say. We're just going to assume whatever we hit is the surface. We're not going to do complex collision detection here. We're just going to do basic stuff. So we don't care if we have multiple contact, like I guess you could have, or as you're resolving you hit another one. We're just going to, like, the first thing we hit, or the first thing that we think we're going to pass through, then I think we're going to just count that surface as a collision. So it's really easy with the outer walls, because like we can just test if we're like out of bounds, right? So I'm going to try and do 0, 0. So this is going to be 0 on the width, and this is going to be on the x, and this is going to be 0 on the y, if I understand this correctly. And so I think what we're going to do is we're going to go down here, and then if ball pause dot x is less than equal to 0. Oops, we don't need those. Then we are going to undo the movement. Could get fancy here. Okay, so get the leftover velocity, change velocity vector reflect, and then so that kind of opened up a can of worms, that if we are in a corner and after we did do the reflection, then I'll need to step through the physics again, but it's just the ball. So I think it's not that big of a deal. Oh, I guess it's just ball pause right now. Ball pause dot x times -1. Right, so we're gonna have to do more math if we're on the other edge, and we'll kind of formalize the collision code later. But like right now, I just want to focus on that one case. So what we're doing here is that, whoops, oh, we can close that. Basically our center point is going to be out of bounds by some negative number, right? And so we just want to move them back to 0. Oh shit, I I didn't take in. Okay, so yeah, I think we're gonna step them back to 0. And then that might be complicated. And then we're just gonna move the +2. Right, so we're just calculating how far out of bounds we are, then we're walking that back, then we're gonna reflect the angle, and then we're gonna move that amount again. Now I'm just thinking in the one axis, but like if we're on a vector and we have to go back on a particular axis, we have to figure out how much we're going back on the y too, and like kind of walk that back. And walking that back might not be a good idea. Like there might be a different algorithm to kind of just figure out where the point that we hit at is, and then adjust our velocity, or make like a new velocity to get us there, then reflect the vector, then subtract that new velocity from our ball velocity to figure out how much we want to move, how much actually we want to move this frame. That's kind of getting complicated. I'm probably just going to do something dumb right now. So let's just worry about the x-axis. We'll do the fancy stuff right now, just only against the x-axis, and we're just going to ignore the y-axis for now, because that's easy. And once we get that working, then we will go back and figure out actual vector logic. And then I also need to, I need a stand apparently. Thank you, watch. Vector reflection. Give me, that might be good. Oh, this is not what. Oh, okay, yeah. Yeah. So I don't think it would be the normal, would it? That's not going correctly though. I don't think that's going in the correct direction. Oh, I'm doing a ray tracing exercise. I have a vector representing the normal surface at an intersection point. And a vector of the ray. Add spins. Yeah, I think it might be the wrong type of reflection, but all I want to do is I want the velocity, so of the ball when it hits a surface, I want the velocity vector to be changed into that. I don't know if that's reflected or flipped. I don't think flipped is the correct way either, because that would just be pointing down into here, which I don't want. I want it like bounced, if that makes sense. Here, I'll come back to this in a little bit. I need to stand up, get some water, and go to the bathroom. I'll be right back, and hopefully, I don't know, what he's trying to do looks like what I want, but I don't know if, is it just dot product? Oh my gosh. It must be normalized. Oh, maybe it's just a dot product. A matrix. Okay, I'm gonna take a break real quick, and I'll come figure it back out. Yeah, I don't know if I don't know enough math, but yeah, I'll figure something out. Be right back. I forgot to mute. A lot of balls collide with each other. They have different masses and sizes. Hard to make it true to physics laws. Yeah, physics is difficult, especially in like simulation, like, right? Because like you're just doing time steps, and if like something happened in between time steps, then you kind of have to like figure that out and like go back and kind of like do the correct thing. So like it's crazy. Okay, what does Wikipedia say about vector dot product? How did I forget about dot product? Math is fun. Here are two vectors. Cross product. This is, I don't know if this is what I want, because this just finds, because that's AP, Y. I don't think this is what I want. D, or D, and this is dot product. Oh, okay, here we go. So, result, okay. So R is D, and okay, so the normal. Okay, so the D is the direction vector, and N is the normal of the surface we're hitting. Okay, so we're going to take D minus, oh, interesting. Okay, so we're taking the dot product between D and N, multiplying it by 2, scaling that by N, and then taking D and subtracting it by that result. But why? No idea how this works, but it works. And that's all that matters. Yeah. Yep. Here's my understanding. dN is the length of the D along the direction of N, i.e. the projection of D onto N. Multiplying by N turns the scalar dN into a vector of length D along the direction N. If you subtract this from D, you would remove all of the N direction character from D, perpendicular to N, and it would be parallel to the B in the diagram. Okay. Subtracting again yields a vector that is reflected back since you're defining. Oh, okay. Interesting. So old with the AI. Yeah, I know. Sometimes I ask ChatGPT things. I usually get discouraged because it's like not right all the time, and I would much rather just try to figure it out myself. Maybe not figure it out myself, but like just try to. Like I'm trying to accomplish something, so I'd rather just like hunt for something that tells me what is true or what is like actually like giving me correct information. Now if like there's information, like I'll ask it legal questions because I don't know if it's right or not, which I probably shouldn't do now that I say that out loud, but like sometimes if I'm just like, oh, like I don't even know, I don't have an example, but sometimes if I'm like trying to search for something on the internet in Google or DuckDuckGo, or I don't use Bing, but like the search engines I've exhausted, and I'm just like, nothing is telling me this information. I might ask ChatGPT, and they might kind of steer me down the right path, or use different words that I wasn't using in my search before, and now I can use those words to kind of verify, like, oh, what does an LLC mean? I know what an LLC means, but like, just an example, like I wouldn't know what a corporate structure was, and I'd ask ChatGPT, what are corporate structures? And they're like, LLC. What are the other ones? Not sub 2, Corp S and Corp C, or all that stuff. Okay, so I think I understand this now. So So we're gonna have our reflect. I should not call it reflect. We'll call it R though. So we're gonna take. Does pygame have a scale? Scale to length. Oh, whoa! It has reflect. Is this what I want? Is this what I want? Reflect returns a vector reflected of a given normal. That sounds like what I want. Off a surface characterized by the given surface normal. Dang it. We learned all this cool math. Do we be stubborn and just... Here, yeah, I think we're going to be stubborn. I think we're going to do the math real quick. Does it... So it has a dot product, that's fine. We can multiply it with a float, so that's fine. Okay, so then that means I think I can just do everything. So we're going to go back here. So our direction is going to be our ball velocity, right? And we're going to subtract 2 multiplied by the dot product of ball velocity dot on the normal. So since we're just checking this one wall, we just know that the normal is positive 1, 0. Because we're starting up here and we're increasing in that way. Right. So yeah, we just know that it's 1, 0. I don't know why I drew my 0. I never draw my zeros like that. I always do it counterclockwise, I guess. That's weird. I don't know why that's weird. Saying out loud, saying I draw it counterclockwise is like, why would I do that? Maybe because I'm right-handed and that flows into like my arm, into my body instead of going like outside of my body. Oh, do I just have to create 1, 0? Sure, that's fine. And then we okay, so that's still a scalar. Okay, yeah. And then we multiply that by the normal, which is shoot. Let me just make a normal pygame vector 2, 1, 0. Delete till the second. Oh, delete till that one. And then normal, and then times normal. Okay, then I want to print R, and then I want to print ball velocity dot reflect normal. Uh-oh. Shit. Oh. Cool. So I assume those are both the same answer. Maybe I should have made that a little more clear. How do you concatenate in Python? My reflect. Do I just do one of those? Oh, that made it terrible. Okay, there we go. Cool, okay, so they came up with both of them. Alright. Well, that's good that we know how to do that, but I think I'm just going to use their reflect. Copy that, reflect, vector reflect. I guess I should. Oh. Sorry, I'm thinking like it might get stuck. I'm thinking how to resolve like getting it stuck. Because if it does it, if we move it now, how much do we want to move it by? Also, I don't think we need R. I think we just want ball velocity. This returns a new vector, right? Yeah. Okay, so I think we just want ball velocity to be this. Ball velocity to be that. Okay, and then I think what we want is leftover. Do we want leftover? Leftover is not a vector. I think I just want. So what percentage of the velocity are we going to move? I think is what I want to calculate. So leftover over 350 times dt. Do I want to multiply by delta time? Sure. Fuck it. Wait. Yeah. Okay, so everything's going to be in delta time. Whoops. Undo. There we go. Okay. Print. Oops, that's not a thing. Fuck. Oh. That was cool. That worked. I was thinking that was gonna get stuck. Okay, well let's try and make it like do a crazy big one, because if the correction this frame I think is smaller than let me lower the frame rate, because I'm afraid that if the correction this frame is lower than or is greater than the radius, then I'm afraid that it's going to get stuck off screen and we're going to keep reflecting the vector, which might be bad. I also want to print Oh yeah, I didn't lower the frame rate. Be a monster. Oh no. Ooh. Hmm. Huh. I guess that works pretty well. Um, okay. Whoops. Alright, cool. Let's get the other walls. So by doing this like this, I'm going to quickly see what I need to move into like its own like collision function, and I'll be able to kind of abstract, refactor. We'll use refactor. I'm going to leave those all in there. I want the debug statements, but we're just going to do another leftover. Pose.y, oops, times -1. This will get tricky on the other axi. Vector, oops, vector 2, 0, 1. Velocity. Oops. Oh, what is it not happy about? Oh yeah, we just completely ignored the other axis, so it's probably not correct. We'll need to do that later. This should bounce and then bounce again with no debug. Yeah. Cool. Alright. And then now, if stop y is greater than equal to, maybe we do x equal to screen dot get width. Yeah. Okay, so at this point, I think it would be wise to make a function, because I don't want to make these freaking if statements every freaking time. Getting ahead of myself, but I'm kind of trying to think about how to like make this also workable for the blocks. But I think that's a very different problem, because I'm basically treating these like planes right now, like lines basically, and boxes are not lines. So maybe I just have two different systems, one where I can do planes and another where I have boxes. Because I guess the first thing with the boxes is that I need to see if there is a collision detection, and then I need to detect what face, or like what face? What segment, what line segment I hit. And then from there I might be able to reuse some of these methods that I'm about to make. Yeah. Okay. So let's see, we take in the ball velocity. Can things be passed in by ref? Python by ref. Oh, there's a ref keyword. Oh, is this only for ints? It works. It does work. Yeah, we do have it working. Bloop. Bloop. And then we're writing that now. So I wonder if structs are always by ref in Python. Or if they're by value. Go away. There's no pass by reference in Python. Just modify the passed in point. Modification will be visible from the calling function. Okay. So I think classes, it looks like classes are passed in by. Yeah. So I assume those are passed in by reference. Let's see. So what do I want? Okay, so I think the two things that I want the okay, so it looks like I can pass in. Oh, but it doesn't know which one. Fuck. Here, okay, I'm gonna make this one because this one might have to work a little differently. Leftover equals. So this is ball pose dot x. I think this is gonna be a positive number. So I think we need to subtract screen get width, which I think we could probably do something similar here, where we're taking like 0 minus ball pause. Oh no, this is gonna be different. So so what I was thinking is I would pass in ball position and then ball velocity, and those would be by reference. So anything that's moved or anything that's changed would be reflected, and then I'd also pass in the normal, because the normal is the thing that changes, and then it would calculate the leftover. Well, this is where it kind of ran into problems, where I was like, well, it doesn't know what axis it needs to be reflecting about. Does that matter? Should I change this to make it not should I think I should make this more generic and says specific. I should be able to pass in the ball position, a normal, and the ball velocity, and then it modifies the ball velocity and ball position, and then it also it corrects the ball position for the next frame that we render. So I think that's the thing. So then what I would have to do is, instead of doing leftover as an axis, I think I would have to figure out I would have to like walk it back or calculate the difference between where I'm at, where what we collided with is, and then go from there. I don't know exactly how to do that, so I think I'm just going to crank out the code, and then we're going to see the differences. Or I guess more importantly, the similarities. Might have to take a break. My wrists kind of hurt. Times 350 dt. Might have to do some stretching. Alrighty. And then so if ball pose dot y is greater than equal to screen get height. Whoopsies. Oh, I guess I don't need those. See, that's what I'm saying. I might just be more comfortable with raylib and C. But the problem though is that I don't want to I don't want to fall into the trap of like, oh, I'm going to make an engine instead of making a game, because I do that a lot. And the whole point of doing it this way is that I kind of focus on gameplay or game systems and how they interact. Velocity. I should actually, that's what I should do too, is I should find something that's a little better autocomplete for my NeoVen. Maybe I'll work on that today. I have a bunch of other stuff I need to do. That's a bug, right? We don't want that. That's also a bug. Nope, that's a bug. Oh, I guess I don't have to put the... Okay, so this should, unless I fucked up. Oh yeah, here, let me... Oh no, wrong buttons. Go back, no, stop it. I want to make sure I'm calculating those correctly, because those should be positive numbers. Whoa. Yeah. Whoa. 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 Oh! That was exciting. Where's screen? Oh, okay. Whoops. Forgotten me. Actually, just do that. Okay. And we don't hit it. We don't collide with it yet. Cool. So that's awesome. Let me make it faster to hit all sides. Goodbye. Nice, awesome. I guess the next thing would be to get the player to actually interact with it. And then after that, I think we just make the breakout, the other cubes, because I think the framework would be done. And then we can juice it, add some like screen shake, which might be difficult. Well, I think there's a camera. There's a camera concept for pygame. Maybe add like power-ups to make your character longer or faster. That might be fun. Really do want to refactor this. I don't know if it'd be worth it. Maybe. Let's see. Ooh, that was a lot. How do you nudge it up? Control Y. There we go. All right. So I guess. Would you be interested in checking out my open source project? Sure. What is it? Do you want me to view it on stream? Stacks, you said. Can you show me the person? Why users? Stacks. Dart. I haven't used Dart. Oh, cool. There's a way to reduce the burden of creating commits, branches, and PRs so it doesn't consume much of your time. As a result, you can start creating more PRs, small changes, easier, faster, at the same time. Okay, cool. So will this... Oh, cool, okay. Flag adds all the files to staging area. Direction PR page. Oh, cool. Interesting. I've only done one PR because I am terrible with open source software. But yeah, I did find it very cumbersome that, well at least I did a Godot bug fix that someone else ended up fixing. But it was a nice learning experience. So how they recommended you do it is that you fork the branch, or you fork the repository, and then you make your own branch, and then you commit to that branch, and then you request that that branch goes into a pull request, which is very cumbersome. So does this help automate that? That wasn't bad. Command line interface. I'm not familiar with Dart. What does Dart look like? Oh, okay. Cool. Yeah, I'll check this out. Like I said, I don't do too much. Oh, stacks commit. PR, branch and commit name. Branching. Oh, okay. So it's a combination, or it takes inspiration from JavaScript, Java, and Kotlin, or is it like a super language, like a superset language, and it can compile or transpile back into JavaScript, Java, or Kotlin? Actually, I can just look at Dart. You don't have to explain it. You don't have to explain basic things to me. Oh, this is. Oh, okay. Okay, cool. Neat. Dart was like JSP2, some Java features, then they got rid of JS, and later added some features from Kotlin. Oh, okay. Interesting. Yeah, I'll check this out. Throw that into my game dev and code. And usage of Dart as a language for cross-platform UI framework Flutter. Oh, okay. Man, yeah, I'll take a look. I'll keep that in mind next time I do like a PR. I've been meaning to kind of do more open source stuff and just contribute back. Definitely pad my stats on GitHub, but also I use a lot of open source stuff, even though I'm on Windows. So I'd like to kind of contribute back. But yeah, I'll. Do I use GitHub for work? No, I don't. Not right now. We use Perforce. Yeah. It's I wish we'd use Git, but it's not very good. We have a lot of yeah, Perforce is old school. It's because we have a lot of art assets. It's game development, so we have a lot of like art and sound and engine component or engine like artifacts, I guess. So like everyone just uses Perforce. I haven't used Git professionally for like 3 years. Yeah, I know. I know. I think Git LFS would be fine. I don't know though. Everyone just uses Perforce. Everyone already has Perforce set up. They already have their custom servers, their on-site infrastructure. So I mean, I don't know. If it was easy for them to make a in-house Git server with Git LFS enabled, I think that would be way better. But I don't think GitHub as a hosting solution is good for. Not good. I think there's security concerns is what I'm saying, and everyone would much rather have just on-site, on-prem like servers instead of trusting someone else's server. But that's kind of the nature of the business. Yeah, I'm familiar with GitLab, and I personally use Git. It's spelled weird, like that. I guess I could have done it Git here. Yeah, that's when I determine that my side projects are good enough to be put into source control. I use my Git instance. Oh, how do you find line intersection? There was a way to do that, I think. I've done that before. What did I do that for? And why did I do that? Two lines intersect. Oh, I don't want algebraic. No, I don't want, I know the lines. So like what I was thinking here is, so I wanted to do the leftover stuff better because I just wanted to express all of these instead of the specific X and the specific Y. I wanted to express these as vectors because then I think, or I hope that if I do it in terms of vectors, then I can just pass in like the normal, I can put all of this code into a function and just pass in the specific ball pose, velocity, and then the normal for that collision. And hopefully that method will be able to be reused. So like what I want is like, so we've hit, right? So we've detected that where A, B, O, and C, D are the lines. Oh, okay, yeah. Or A, B, sorry, and C, D. Yeah, that's what I said. Okay. Yeah, so like this line, basically the line from here to like when we go out of bounds. That line, and then I want to figure out this path. So we would have a line of like wherever the ball pose was, and then wherever the ball pose is this frame, or is going to this frame, and then we would have 0, 0, 0, and then I think that would that be the length? It would be screen dot height, and then we'd figure out in pixel coordinates where that is. Right, yeah, right now it's just coordinates. Right now I don't have like walls. I probably should just move it to a block. But like, yeah, right now I'm just like, 0, 0, 0, 0, or 0, whoops. So this edge is 0, this is 0, because 0, 0 is up here. And so yeah, I'm just detecting like, if the ball is less than 0, then like that's a collision, and then I do the math to reflect the vector. So yeah, like I think it wouldn't be too bad. So if I vectorize the whole thing, then not only do we, instead of just pushing the ball on the x-axis or on the particular axis, we actually like go back in time, if you will, instead of going out to here and then being pushed that way and then moving across the vector, we're going to be pushed to here and then have the vector. I think that'd be more correct. So yeah, I think finding the line intersection between where we're out of bounds now and where we were, and then with the the coordinates of that, the frame of the screen. Why did it format it this way? That's so weird. That's right. Where did I do that? I've done this before. No, maybe it wasn't in... Where was it? Was it in projectile? Whoops. to main. Do twig. Process keyboard. Process game. Game samples. Create player load resource. I don't think it was this one. Maybe this was in Zig. I might have deleted it. I probably deleted it. Was it in warp speed? I don't think it was in warp speed. I don't think I had collision detection in warp speed. What is your coordinate of the ball and radius? The coordinates is just pixels, like everything else. So the ball, where is the ball? So yeah, we have ball position. Oops. And then ball velocity, and then the circle is, so the ball is 5 radius. I believe that's radius. Yeah, that's radius. Man, I swear I've done that before. Okay, that's fine. This way, that's fine. Yeah, so that's kind of what I was doing here. So I calculate the leftover, and like I go back, or I go that far, I guess, in the opposite vector, but instead of instead of doing that, I wanted to move along the vector. You know what? I wonder if this is even needed. It's about touch point coordinate. Yeah, so that's fine, but like the problem though is that yeah, but like I wanna do it vector based, because right now everything is being calculated based off of the component, the X or the Y, and we just have to know that. So if I make it vector based and calculate everything based off of the vector, oh, hold on, what are you saying? Oh, I see what you're saying. Oh, okay, yeah. Yeah. Whoops, not C. I don't know. Right. Yeah, for left wall. And then for top, it'd be ball X, comma, 0. And then it would just be, I think, screen width. Yeah. Right. You did a math paper? Wow. So that still moves. Okay, cool. Nice. Wow. Add spin. Like, instead of just colliding where it kind of like rolls off the wall. Yeah, that'd be fun. That'd be interesting. Oh, that's hard to see. Is that a favorite? Oh, cool. Thanks for the follow. I just changed like my alerts, so like it was up there on like a white background, and like I think it was white text. I'll have to fix that. But thanks for the follow. Oh, what time is it? Oh, it's almost 4. Yeah, I think that's good. I'm kind of slow right now. Yeah, I think I'm going to end the stream. I might be on tomorrow if I have time. Yeah. I think tomorrow, hopefully, I'll get this more generalized so we can maybe use it for the player. Daily stream too. Oh, cool. Yeah, I'll drop in your stream here maybe later. A little later. I need to go lay down for a little bit because I'm kind of tired. But yeah, I guess I'll see everyone later. Bye-bye.